Fundamentals. What is light? The electromagnetic spectrum. Most of us can only distinguish 6 colors of the rainbow with our eyes: red, orange, yellow, green, blue, and violet. But William Herschel discovered in 1800 that there was another type of light below the range of red light, which he named infrared. 1 year later, Johann Wilhelm Ritter discovered ultraviolet or UV waves at the other end of the visible spectrum. Today we divide light into categories according to wavelength. There are 7 categories: radio waves, microwaves, infrared, visible light, UV, X-rays, and gamma rays. Our main source of light, the sun, emits all these types of radiation. Regardless of category, light can be described as a wave and always travels at the same speed, just short of 300,000 kilometers per second. All types of light can be described with just a few characteristics: wavelength or frequency, and amplitude. From the length of the wave, we can establish the category of light. The frequency describes the number of oscillations per unit of time. The shorter the wavelength, the higher the frequency, and vice versa. We calculate the intensity of the light using the amplitude. The various ranges of the electromagnetic spectrum all have applications in scientific research. Scientific imaging harnesses every wavelength of light, from gamma rays to radio waves, to bring the workings of the universe invisible to the human eye into the visible realm. Wilhelm Conrad Röntgen became the very first scientist to win the Nobel Prize in Physics for his discovery of X-ray radiation in 1895. Today, light can even be used to obtain precise scientific measurements, as Serge Haroche describes.
Now the clocks are based on the oscillation of an optical transition in atoms. What you do is that you send a very stable laser, which is locked to the top of this very narrow transition, but then you have to count the period. And the way to count the period is to compare this laser to what is known as a frequency comb.